I will now request Mr. Satish Nair, Director of Technology F5, to speak on the topic of driving agility in the cloud. Over to you, Satish.
Okay, thank you all for the warm introduction. Today I'm going to be talking about driving agility in the cloud and how do we get cloud ready. Some points that I intend to cover today are the borderless infrastructure, what it means to be cloud native, Cloudify, and getting cloud ready. So what is a borderless infrastructure? Borderless infrastructure is F5's depiction of what we want to understand as seamless application mobility. The application space as we know it, these are times that we are living in today or we'll be living in soon. We all started life running applications on physical servers, one application to one server, a given amount of compute, a given amount of memory, and a given hard disk capacity. Everything about this world was limited with only one application running to one physical server. And while this sounded very nice and very easy to manage, the guys at VMware, the guys at OpenStack and Hyper-V had a different idea. They came back saying that you could now pick this physical server into smaller virtual servers and run applications on each of these virtual servers. That was the advent of what we call the hardware virtualization technologies. This was better than sliced bread, but CIOs just thought, this means now with the same physical server, I could run more applications, means better ROI. Things did not stop there. The big three walked in, the Azures, the GCPs, the AWSs walked in, and they said, all you need to do is get the application to us. Everything from compute, storage, networking, security, access policy, etc., is something that we will give you and maintain the same for you. This was even better than hardware virtualization. Well, it seemed better because when the monthly bill hit them at the end of the month, that's when the CIOs realized that what sounds really cool might not really be that economical. So today, customers is caught between a physical server, a hardware virtualized server, or a public cloud. As of to say this is not enough, a new breed of technology that's come out is called the OS virtualization technology, wherein the OS is basically what gets virtualized on a given hardware, but allows us to run multiple copies of the same application and multiple applications on the same operating system. This had better ROI than any of the other options previously available to the customer. If we thought life was simple here, it did not stop here. Customers came back saying, today, I still run an application on physical servers. I have already invested money on running VMware and OpenShift. That means I already have hardware virtualization installed. I already have containerization as a program in my organization. And I'm also going public cloud, but this time with a twist. This time, I want to run the same platforms that I'm running in my on-prem environment on the public cloud also. So on the right-hand side of this image is what is a complete mashup of everything that an IT manager knows. It has both hardware virtualization, it has both containerization, it has got public cloud and everything in between. This is what customers are expecting today. But customers are generally asking for more. So what is happening now? Customers are saying, I just want them to be seamless, which means I don't want to be bothered about creating the infra and running an application on infra. Rather, I just want to focus my energy on deploying an application. The system should be automatic to understand that, I'm going to deploy an application on my infra. This infra could be made up of public cloud, private cloud, and different technologies within these clouds. The system should be intelligent to understand when I deploy a particular application, how should the application actually be deployed in any infra? And that application should be able to manage itself, monitor itself, and also self-heal. This is exactly what we mean by the seamless application mobility. And this is where the world is going to. The second important thing that seems to be happening is in our parlance called the tectonic shift. Customers moving from monolithic architectures to microservices-based architecture. The point of the slide is, we have this large application that used to be earlier deployed in every organization. Think about the Central Railway Information System, wherein they have this huge ticketing application. But today, they're considering breaking it down into smaller components. These smaller components, as we understand, are microservices. Microservices themselves have gone through multiple rounds of evolution, starting from microservices running on bare metals to microservices running on hyper-virtualized environments to now microservices running on container environments. This tectonic shift compared to the mashup of all the infra that we saw in the past is the reason of chaos. And that is one of the reasons why a company like F5 comes in and allows us, rather we bring in our technology and tell our customers that there are ways to manage this madness and there's ways to ensure that you get the maximum efficiency out of your infrastructure, and you need to just focus on the application at hand. So a few things that are really going to shape the applications of the future. One, customers will deploy applications on multi-cloud. The reason for customers deploying applications in multi-cloud is primarily to hedge their risk and cost control. Customers are going to adopt containers and microservices for reasons of scalability and resiliency. Applications are not going to talk to each other the traditional way. Rather, they're going to make API calls to each other and get the services done. Gone are the days when you would define an application by designing a physical server, the operating system involved, the application framework involved, and then deploy the application. Today, the entire DNA of the infrastructure and the entire genetic inheritance of that application on top of this DNA is what we call the infrastructure and application as code. It's basically a scenario wherein we're able to abstract the definition of an entire infrastructure, all their applications, into simple text files, put the two text files together, and spin that infrastructure and the application on any platform of your choice. So the entire logic or the DNA of the application, the DNA of the infrastructure on which the application runs is coded in a piece of text file, a simple text file that can be mutated and deployed in any platform. That is what we call infrastructure as code and application as code. If you're going to take your applications to the cloud, wherever the cloud might be, you want to also ensure that the data it services or the data it's running on is also protected. So data security at rest and in transit is paramount. Customers are not going to come and tell you they want security. It is implied that security will be a part of your offering to the customer. So what does it mean to be cloud native? Cloud native is a very esoteric term used for a very simple concept. It basically says that it's an umbrella term. Basically, that says that it spans both technology and process with an aim to improve human and machine efficiency. If you look at it right, there is nowhere in this definition it talks about a specific technology. No, it doesn't talk about a specific technology. It just talks about the processes around the technology that you require to have to ensure that human and machine efficiency is at its maximum and errors are at the minimum. Cloud native fundamentally addresses three services. The three services are infrastructure services, the application services, and the packaging and deployment of these services. These are very long discussions, but fundamentally, it relies on three very, very important tenets. First, whatever infrastructure you decide to deploy an application on, it should be programmatically addressable. It should be dynamic and decoupled from the physical layer, which means I should not have to go and log in into an AWS to configure an application on the AWS. Rather, I should be able to log into my laptop, open a small text file, put the logic of the AWS on that text file, and let the program do things on its own. That's what we call programmatically addressable infrastructure. Second, applications are going to be distributed and decentralized. Our focus, therefore, should be on not where the application is going to be running, but how is the application running. So this is very important because now, as a company that is focused more around building or promoting the concept of a seamless application mobility, it is important that we understand and appreciate that customers today are not asking where is the application running, but rather asking how is the application running. So this point of a distributed and decentralized architecture is very, very important. And last but not the least, resiliency and scalability with no single point of failure is a fundamental tenet of a cloud native architecture. So 3 points to summarize here: programmability of the infrastructure and application, deciding how the application is to be run and not where to be run, and ensuring there's enough scalability and resiliency built into the system so that there is no single point of failure. So what is Cloudify? So Cloudify is our take and our positioning as to why we feel the F5, Nginx, and Shape story all come together in enabling the customer in their cloud journey. In our world, in F5, we call this the code to customer. So I want to break this problem down into three very, very simple tenets. The first is the application estate. The second is the network estate. And third is the user estate. The logic of these three estates is very simple. Whatever we do to access an application as a user or somebody who's delivering the application, there are only three regions or three domains that any user would touch. The user estate, wherein the user is trying to access the application using a mobile handset, could be a laptop, could be a desktop, could be a mobile phone for that matter. As on his path towards the application, he's going to go over a network. That network could be an MPLS network, could be a public internet connectivity, could be any form of connectivity, even wireless. That is a network estate. And thirdly, is a data center where the application actually runs. This could be a physical data center within your own premises, or it could be a public cloud, or it could be a combination of both of them. But whatever you can think of, between the client accessing the application and the application, they'll fall in one of these three estates. At F5, F5 addresses all three estates. Not only does it manage all three estates, it also adds two additional estates. The two additional estates that we added are the Silverline Managed WAF service. This is F5's managed security service. So if you want to deploy security services for applications on a private cloud, F5 has a cloud service called the Silverline Managed WAF service. The entire SLA of managing security for your applications is managed and maintained by Silverline. In addition to the Silverline Managed WAF and the DDoS protection services, we also have a self-service portfolio from F5 called the F5 Cloud Services. This is where customers can go in and buy their own services on demand. Imagine a case that you want to buy a layer 7 firewall and you want to just go and deploy one. You could log into the F5 Cloud Services portal, swipe a credit card, get a WAF on demand. In three basic steps, you'll actually deploy a layer 7 firewall from F5. The F5 Cloud Services is a self-managed cloud service, whereas the Silverline Managed WAF is a F5 managed WAF service. F5's portfolio spans all the way from the client side to all the way on the server side. Be it DOS protection, be it bot protection, be it SSL management, be it infrastructure management, anything, security, load balancing, all of this is what F5 covers. Last year, F5 acquired Nginx. Nginx today is very, very strong on the cloud and data center space. The largest deployments on microservices today are on Nginx. Nginx also has a very strong story on the network layer, on the ADC layer. So if you look at this architecture, right, between the network layer and the application estate, the Nginx deployments rules the roost. Sitting on the network layer, Nginx can do things like load balancing and security. But sitting in front of the application, Nginx can do API load balancing, could do bot prevention, could do rate limiting, can also do microservices load balancing. This is where Nginx's focus is on. Early this year, we acquired a company called Shape. Shape is the #1 company when it comes to protection against fraud. Shape, as we have been promoting Shape as a fraud protection service from F5. Shape allows us to look not only at the client-side devices like a laptop, mobile device, anything, it also has installations on the data center end. You could deploy Shape as a part of your application service. Shape also is available from the F5 Silverline Managed Services and also from the Shape Cloud itself. So Shape today provides services like anti-bot, API protection, web scraping, credential stuffing. All this is a part of the Shape portfolio. Now, if you look at the Shape story, the Nginx story, and the F5 story, we were able to put them all together in one single platform and ensure that we're able to run all these services between the client and the customer, between the client and the application. This is the story of the three estates. If you look at it right, a user today has the option of buying any service from F5. When I say F5, I mean both F5, Nginx, and Shape. You could run any of this service in any format, either physical or virtual, or even on the cloud, anywhere at the swipe of a credit card. You really don't need to be tied down to a physical infra. You could basically go out and decide how do you want to protect your assets or application assets from whichever option that we present to you. So how do we get ready for the cloud? F5 has been pushing this strong belief that all things are code. What we're trying to say is that it is very much possible to define and deploy infrastructure and application services through reusable software code, and it doesn't really depend on platform. It basically means, right, I should be able to define my application and my infra once, put them together, and deploy a service. To illustrate this further, it basically talks about three things. It talks about the infrastructure readiness, it talks about application readiness, and it talks about programmatic interfaces. Infrastructure readiness is all about where do we deploy the application? Can we extract the infrastructure to reuse the same? Look at it this way. Let's assume that you want to deploy an application on Amazon Cloud. I should be able to define Amazon Cloud as a piece of software. Likewise, I want to deploy an application. Let's say I want to deploy an API gateway today somewhere. I should be able to define an API gateway in some software construct. Now, this API gateway might also have some other dependency. For example, you might say API gateway requires access management to the front-ending an API gateway. That is where you define the application dependency. And third, this definition that you created for the application and the application dependencies should be completely independent of the infrastructure it runs on. So the first two pieces are really the two important pieces. The first one defines the infra where you're going to run the application service, and second is the application itself and the dependency around that application. But the most important thing that we need to understand here is the glue that basically stitches the infrastructure services and the application services into one unified framework, and that is what we call the programmatic interface. The programmatic interface basically takes the infrastructure services, the application services, puts them together and deploys them on a platform of your choice. So it's something, in all graphical terms, it looks something like this, okay? There is a device definition. It could be a public cloud, private cloud, or on-prem. There is a service definition, which says this is the application. It is going to be running on this particular location. This is the application definition, and this application requires the following dependency. And last but not the least is where we are saying, once the application is deployed, I want to start metering the application to understand how is the application really performing, what we call telemetry streaming. In F5, this is called the automation and the orchestration tool chain. Okay. Simply put, look at it this way. There is an infrastructure definition, which means that I have a small text file. Think of it as a text file. It's easier to understand that way. A text file that defines your configuration for Amazon or VMware or Azure or GCP, or for the matter, even Kubernetes. There's a text file that defines the infrastructure. Similarly, there's a text file that defines your application. Now, this application text file is independent of the infrastructure text file. Very, very independent entities. All of them manage independently. You can mix and match both these text files and deploy the services wherever you want. That is the power of what we call the infrastructure abstraction and the application services abstraction. So today, with F5, Nginx, and Shape, our vision for the future and the things that we are working towards are the path between the customer and the path between the application, which we call the code, has multiple elements in between, starting from firewalls to load balancers to API management services to web servers, application servers, you name it. The entire path in between the client and the application server is something that we want to be playing in and managing them for you, all through software services or software API calls that we can make to the entire infra in between and allow you to stitch a service on demand. So in a nutshell, this is how to look. When you have your definition files ready that you've created, this definition file can be given to any of your orchestration system. It could be a simple application that takes the definition file that you're given. It takes the definition file, pushes the definition file into maybe an Nginx or an F5, as the case might be, goes out, creates those services for you, to spin a load balancer, to spin a web server, to spin a firewall for that matter, and then deploys the services on public cloud. All this that you saw here are driven through programmatic interfaces, all connected via a single DNA called the application or the automation orchestration toolchain. This one toolchain is what allows us to make the entire F5 portfolio cloud native, and also enables you as a customer to go to the cloud. Thank you.
Thank you, Satish, for that presentation.